All right, let's take a look at material cycling. So, unlike energy, which only moves in one direction, most substances are going to cycle through our ecosystem. So what happens with energy is that plants are going to absorb sunlight energy. They're going to make biomolecules with that. The plant then gets eaten by something else, and so that energy converts to that next thing, you know, that rodent or grasshopper or whatever it is. That gets eaten by something else, and so on, right? But through our metabolism, we're going to break down those biomolecules, and we're going to release that energy from our body as heat. So we are constantly giving off heat as body temperature. And all organisms along here are going to break down biomolecules for energy, so they're all going to release some levels of heat to the atmosphere, and then that heat gets released from our atmosphere into outer space. So sunlight energy comes into our ecosystems through plants, through animals, and then through metabolic processes gets released into the atmosphere as heat, and then that heat goes to outer space. So it moves in one direction. These other substances are going to cycle. So the first is the water cycle. So this is showing the environmental water cycle. And here, water vapor in the atmosphere condenses. Basically, we're in a warm air mass, hits a cold air mass. Those molecules get drawn closer together, and then the water drops out of that. Okay? So water vapor in the Earth's atmosphere condenses and falls to the Earth's surface. Then that water on the Earth's surface is heated, and it evaporates, and thus it returns back into the atmosphere. We do this cycle over again. In an organismic water cycle, water enters the organism, and then it evaporates off the surface of that organism. And this is known as transpiration. So, you know, we take in water in us. We don't just urinate it out of us. We lose about 500 milliliters of water off our skin per day. All right? So, this is showing, you know, just a silly little thing of the environmental water cycle. So, one of the things that you can see on this is showing a tropical rainforest is in the background you're seeing these low-lying clouds, and that is from transpiration from all these plants. Okay? So in a rainforest, you can break this cycle of the environmental cycle, organismic cycle, in that tropical rainforest plants are going to absorb 90% of the water that's in rain. So they absorb that water. It doesn't get into the lakes or into the streams and so on. Most of it is taken up by the plants, which then later on the day transpirate that water off of the plants there into the atmosphere. And then that water vapor in the atmosphere contributes to cloud formations, which then causes rain to occur, which then those plants take in. So a lot of the water in tropical rainforests stay in that area. But if you remove the trees here, all right, like in clear cutting, that water will then just move into the streams there and be taken out of that ecosystem. So what happens here is a positive feedback mechanism. If you remove the trees, more water leaves the system, which then causes less water to stay in the atmosphere around a tropical rainforest, which leads to less rainforest. Okay? So, now let's take a look at the water that we have on our planet. So this is showing most of the water on our planet is in salt water. It's undrinkable to us because the desalination process is a very expensive one. This is showing fresh water. This is fresh water that's in ice caps and glaciers. We can't get that. This is the water that is available for us to drink. All right? So a lot of that water is called groundwater. So groundwater is water that's found below ground. 50% of our drinking water is groundwater. All right. This is showing a large aquifer that's called the High Plains Aquifer. So the aquifer is groundwater there. All right. So let's look at I have this out of order. Let's look at the nitrogen cycle first. So nitrogen gas, N2, comprises most of our gases in our atmosphere, 78% as a matter of fact. But nitrogen's deficiency often limits plants' growth, all right? So plants cannot incorporate that nitrogen gas into biomolecules. So what they have to do is they have to rely on bacteria and fungus to make that nitrogen available. And this is called nitrogen fixation. So taking that nitrogen from the atmosphere and putting it into nitrates or ammonia. And then, so nitrogen fixation, the process where nitrogen gas is added to organic compounds. All right, and that makes that nitrogen available to plants. And then that nitrogen moves from plants through the food chain there. And then when anything dies, bacteria in the soil are going to break down those organic molecules, and that releases nitrogen gas back into the atmosphere. So that's a nitrogen cycle. Next is a phosphorus cycle. So the phosphorus cycle, so phosphate ions, like nitrates, are limiting nutrients for plant growth. So they depend upon this for plant growth. So these phosphate ions are absorbed by plants from the soil. All right, these are incorporated into biomolecules, and they'll move through all these organisms through the food chain. And then when any of these dies or has excrement, poop, right, that puts that phosphate in the soil. And when anything dies, bacteria are going to break down those organisms, putting that nitrates back into the soil, which then can be taken up by plants again. And so this is why fertilizers, a lot of times fertilizers are going to have nitrates or ammonia in them as well as phosphates, because both of those things are going to help out with plant growth. The last cycle I'm going to talk about here is the carbon cycle. And this is, so the carbon cycle is, carbon dioxide in the atmosphere is where we're starting here. So photosynthetic organisms are going to take in carbon dioxide and water with sunlight energy, and they're going to make biomolecules with that carbon, okay? So what's going to happen with the plants and all of these animals is we are going to respire. So all organisms respire. So organisms are going to extract energy from those biomolecules, and they're going to produce carbon dioxide as a byproduct. That's why we exhale carbon dioxide. When we break down biomolecules, sugars, proteins, whatever it is, we're going to break those molecules down into carbon dioxide. That releases energy. That's what keeps us alive. And we're producing carbon dioxide as a byproduct. And so we exhale that. Everything is going to respire. So that's going to release carbon dioxide back into the atmosphere. Now, some organisms are going to use carbon dioxide from the atmosphere or from water to make shells. So, we're talking about clams and snails and stuff like that. All right, so they're going to use that to make their shells. But over time, when they die, that shell components get brought into the sediment. All right, so these guys will sink to the bottom, and as more layers are put on top, they go down a little further, and eventually this forms limestone. And even what I write with chalk is made from these old dead organisms. And so that chalk and limestone is mainly made out of calcium carbonate. And so when calcium carbonate gets exposed to rainwater, rainwater is slightly acidic, and so this breaks down the calcium carbonate, and that releases carbon dioxide back into the atmosphere. Okay? Another way that we can release carbon dioxide into the atmosphere is through combustion, and that is the burning of wood, coal, or oil, and gasoline. So we burn it, it releases carbon dioxide into the atmosphere. Now, when we're talking about fossil fuels, so oil, coal, gasoline, diesel, that is carbon dioxide that was removed from our atmosphere millions of years ago. And when these organisms died in large areas, so a lot of this was like algae and plants and so forth, they get compressed over time, and that organic matter gets turned into that fossil fuel. And that's why we call it fossil fuels, because it's made from living organisms that once lived in the past. All right? So when we take coal or oil or out of the ground and we burn it, that releases carbon dioxide back into the atmosphere. So carbon dioxide that had been sequestered millions of years ago is now released. All right? So the last thing we're going to look at is carbon dioxide and the global climate. And I have another video I did for another class, the exact same material. So I'm going to lead you to that video next.